Hello, in this video I'm going to show how to make this platformer in Unity. You're going to be able to walk around and jump on all of these platforms. We're going to be able to change the speed settings as well as the jump force. Every single sprite that I'm using throughout the video in this scene will be available in the description. So to get started, you want to make sure that all of your platforms as well as the ground layer actually have their own layer called ground or whatever. You can do this by going to the layers, add layer, and just adding in layer like so, right? So once all of your platforms and your grounds objects, which obviously should all have some colliders, as if we got the layer, we can actually start working on adding the player. To do this, right click on the hierarchy, click create empty game object, and let's call this player. Let's give it a graphics object called GFX, in which I'm gonna add a sprite renderer component like so. I'm gonna go to my player sprites and select the correct sprite. Then I'm gonna zoom in and quickly disable backgrounds. Inside our player, I'm gonna add a box collider 2D, like that. And you want to make sure to only cover about the top half of your player, like that. And that's because we're gonna add a second collider, a circle collider, like so. You also wanna use this one to fill up the bottom half of your player. Something like that. Now that we have this, also add a rigid body component to the player. And make sure to set the gravity to 5 and freeze rotation. Now let's think for a minute about a platformer, because it's a little bit different than a top-down game in terms of how easy it is to just start implementing movement. You see, we can't always jump. We can only jump if we're on the ground, which means we need a way to detect whether or not the player is on the ground. Now, to do this, we're going to use Unity's physics engine. And this is essentially going to allow us to scan a certain area and get all of the colliders in that area. And because we've added the ground tag to our platforms and our ground layer, we can tell Unity to only give us the colliders that have this ground tag attached to the game object, which will tell us, depending on the size of this array, whether or not the player is on the ground. So to do this, go to your player, right click, create empty game object, and create a ground point. You want to lower this ground point a little bit, just below the feet of your player. Then we're going to create our first script for the player. Create a player controller script called player controller, like so, and make sure to attach the script to your player. And once that's done, double click the player controller script, delete all of that since you don't need it. Now in here, we're going to want to reference to our ground point game object. So write private game object grounds point like that. Then we're also going to want a private Boolean value called isGrounds. Then we're also going to want to add a serialized field private layer mask called grounds layer. And then also add a private float called grounds radius set is equal to 0.2. So create a function called update is on grounds. And in here, we're first going to want to set is on ground equals to false. Then we want to get every single collider around our ground point that has that ground layer. Do this by writing collider2d, colliders equals physics2d dot overlap circle all. Give it the location of your ground points, give it the radius, and give it layer. Then we can go through this array like that, and essentially if any one of these colliders that we get back is not equal this game object, we can just say is on grounds equals true and return another function. Make sure to call the function as well. If you now go back to our player object, drag and drop this ground point, select the ground layer, set the ground layer to grounds like that. You now press play. As soon as our player touches the ground, we can see that the is on ground check, it goes on. If we move our player around, you see it goes off, goes on, goes on, goes on, off, on. Perfect. Next, create a player movement script. Before we start adding to this script, go back to your controller and at the top, write references in a header. Take that out and create another header called flags. These things will essentially allow you to organize the inspector window, which in a small project doesn't really matter that much, but if you're making some bigger projects, this is going to really help with tidying everything up. As you can see, it's all organized right now in the editor. Now also in the player controller script, we want to have a function, a public bool called is on grounds, which simply returns this on grounds, like that. So now in the player movement script, we first want some settings about the movements. This means a private load called speed, private float called scrum force, and also what this last thing does will become clear in moments. I'm also going to give this a range so you can play around with it from 0 to 0.4. In general, when we're working with physics, we kind of don't want to use the update function. Instead, we want to use the fixed update function, which is called a fixed number of times every single frame. So it'll make sure that all of our calculations involving physics will be the same. How this is going to work essentially is we're going to detect whether or not we should jump or move the update function, and then we're going to actually apply the movement in the fixed update function. To do this, write a private bool called should jump, and also a private float called horizontal movement simply equal to 0, like so. So in the update function, we also need a reference to our player controller and also a reference to our rigid body. So now set player controller equals to get component player controller, and also set ERB equal to get component rigid body. Then in update, we want to say should jump equals inputs dot get key down key codes dot space and player controller dot is on grounds. And we want to set horizontal movement equals to input dot get axis raw horizontal times speed, like so. So now in the fixed update function, right, if horizontal movement doesn't equals 0, return. So obviously, if we're not pressing uh, the left or right keys, we don't want to do anything. We can just return another function. Otherwise, we're going to want to actually apply the movement. Now for this, just bear with me for a moment. Create a private vector 3 called vel for velocity, and here create a vector 2 called new velocity, which will be equal to a new vector 2 of which the x component is going to be horizontal movement times time dot fixed delta time, because we're inside a fixed update function, and the y component is simply going to be our rv.velocity dot y. Then we're going to use a smooth damping function to adjust the velocity of our rigid body, and this is what we're going to need this variable for. Right, rv velocity equals vector 3 dot smooth damp our current velocity, which is rv dot velocity, to our new velocity, which is n velocity. I'm going to give it a reference to this other velocity variable, and I give it the movement smoothing variable as well. And now this is actually going to be enough to move around. Now, one thing that I like to do as well is if the player is in the air, which means if player controller dot is on grounds is false, I like to essentially decrease our horizontal movements. So I'm going to set it to 60% right now. And if we now go back to our Unity script, this should actually be enough to move around. So make sure to add the player movement script, set the speed to 5 and the jump force to 800. I actually forgot something. I want to also multiply this by around 100. Obviously, you don't need this. I could have just set the speed over here to 500, but I like smaller numbers a little bit more. I'll press play, and as you can see, we can move around our scene, like so. Now the jumping, create a void jump, which will set should jump equal to false, and it'll add a force to our rigid body, of which the x component will be 0 and the y component will be our jump force. So now inside our fixed update, if should jump, jump. Now before we can go back, we have to change this line, turn it into an if statement, like so. Yeah, so if you now go back, press play, and as you can see, we've got a proper character controller working. Now I will add one more thing, and that's going to be the flipping of the player if we're moving to the left. Because now our player keeps facing the same direction regardless of where it's moving. Create a function called flip, and we're going to want to take the local scale of our transform component. We want to flip the x variable like so, and we're going to want to set the local scale at back. And in our fixed update function, if transform dot local scale dot x times our new velocity dot x is less than 0, which means that opposite signs flip and go back. And now, as you can see, when we move to the left, our character faces the left direction, and when we move to the right, it faces the right direction. I hope this tutorial has been helpful. Thank you so much for watching, and goodbye.